Hello boys and girls, this is Mr. Kizik, and in this video we're going to be looking at function notation. So what is function notation? Well, basically it's an equation that represents a function, so by definition it has to be a function, and it's often written like this here. F and x equals 4x minus 1. In reality, what this means is just that we have a fancy way of saying y equals. By making an equation represent a function notation, like in this here fx, sometimes you see like gx, hx, and whatnot, that just says by definition it's a function. Every x value always corresponds to one y value. So it's read as this: f of x equals, and then in this case here, 4x minus 1. So what does each part mean here? It means that the f of x is the output, or think of it like as your y value, and x is still your input. So why is function notation useful? Well, it says here is especially useful for finding a value in the range that corresponds to a certain domain value. So if I look at this here, it says f of x is equal to 4x minus 1, just like the previous problem, and it says find f of negative 7. What this means is this. So you will see it written like this, f of negative 7. But all that means is whatever's in the inside here, whatever's in that parentheses, you plug it in everywhere you see an x. So instead of 4x, you're going to have 4 times negative 7 minus 1. And then you're just going to do the math. 4 times negative 7 is negative 28, minus 1, negative 29, and there you go. You are done. So let's look at a few examples here. So if I look at number 1, f of x equals x plus 7, find f of 5. So all that just means is that everywhere I see an x, I'm going to plug in 5. So if x plus 7, 5 plus 7, which gives me 12. Let's look at number 3. h of x equals 2/3 x minus 1, find h of 9. All that just means is that everywhere I see an x, plug in 9. So h of 9 equals 2/3 times 9 minus 1. So, and then I'm just going to do the math. 2/3 times 9, well, that would be 6. And then minus 1 would give me 5. Ooh, sorry about that. Let's look at the next one here. It says f of x is equal to negative x squared plus 6x minus 4. Again, everywhere you see a x, you plug in 5. So if you recall what we talked about yesterday with this negative 1 that's in front here, or this negative that's in front of the x squared, what that really means is that you're going to take negative 1 times 5 squared plus 6 times 5 minus 4. And then again, you have to follow the order of operations here. So you would do 5 squared, which is 25, but you got to throw in that negative sign there. And then I do 6 times 5, 30, and then minus 4. And then let's finish it off here. Negative 25 plus 30 is 5, minus 4, 1. And then if I look at number 7 here, it's the same concept. F of x equals 2x squared plus 4x minus 9. So f of negative 5, everywhere I see an x, plug in negative 5. So 2 times negative 5 squared plus 4 times negative 5 minus 9. Following order of operations, this would be 25. And then I would do 2 times 25, so give me 50. 4 times negative 5 is negative 20, so minus 20, and minus 9. And then finish off here, 50 minus 20 is 30, 30 minus 9 is 21. Okay. And that, ladies and gentlemen, is how you would do function notation with numbers inside. So if you got, if you're confused with any part, got any questions, pause the video, go back to the problems, and see what we did. All right, if you're good with that, let's move on then to number 9. So if you look at number 9 here, it's a little bit different. It says f of c plus 7. Find that. So they gave you a function f of x equals 4x plus 11, and then it says find f of c plus 7. What's nice about this here, this is what makes function notation really nice. Whatever is in parentheses, in between the parentheses, basically what that just means is that you take that, so take this c plus 7, and plug it everywhere you see an x. So what that means is that instead of having 4x plus 11, I'm going to replace x with c plus 7. So this is really going to be 4 times the quantity c plus 7 plus 11. And yes, you do have to simplify as much as you can. So distribute 4c plus 28 plus 11. 4c and then 28 and 11 gives me 39. And that would be your final answer. And that is different from the other problems where you were given your finished answer was a number, whereas this here, because you were given an expression, you're going to end with an expression too. So as another example, let's look at number 10. So number 10 says h of x equals negative 9 minus x. Find h of 2k minus 5. So what this means here is that you're going to take this 2k minus 5 and plug it in for everywhere you see an x. Because again, the definition says h of x. Everywhere I see an x, plug in 2k minus 5. So that means I'm going to have then negative 9 minus, now I'm replacing the x, I'm going to put in parentheses here, 2k minus 5. Now I just have to finish it off, so I got to distribute. So negative 9 minus 2k plus 5, because it's negative 1 times negative 5, and then combine like terms, and I would have negative 4 minus 2k. Normally you would see it as negative 2k minus 4, standard way of writing it, but this is fine here. Again, if you got questions, confused on that part, pause the video, go back, rewatch what was just done. Alright, there's no questions with that. Let's move on here. Yeah, we'll move on to this part here. So in this part, it says use the functions to the left. So they gave you 3 different equations. And again, it's another great thing about function notation, is we can have the same variable x in all 3 problems, and I don't need to define a different quote-unquote y value. I could just label it as f of x, g of x, h of x, and there you go. I don't have to worry about other variables. So let's look at number 11. Number 11 says f of 4 plus 9. So you're taking us part by part here. Let's look at the f of 4. F of 4 says this. You're going to take the function f of x, so you're going to use this 8 minus 3x, and plug in 4 everywhere I see an x. So I'm going to have 8 minus 3 times 4. But then this problem also says whatever answer you get, add 9 to it. So that's exactly what I'm going to do. I'm going to add 9. I'm not plugging in the 9 anywhere for x because it's not in an f of 9 or a g of 9 or h of 9. And now I just do order of operations to find a number. So I'm going to do negative 3 times 4, which is negative 12, plus 9. So 8 minus 12 is negative 4, plus 9. And negative 4 plus 9 is going to give me 5. Okay. Let's look at number 13. Number 13 says g of 4 plus g of negative 1. Well, what does that mean? All that just means is now, and again, what's great about function notation is that I can use the same function and plug in different values. So basically, you're going to take g of 4, plug in 4 everywhere I see an x. So I'm going to do 4 squared plus 2 times 4. I'm going to bring this operation down. So plus. And then this g negative 1, all that just means is that I take negative 1 and plug it in for x everywhere for the same function. So I'm going to have negative 1 squared plus 2 times negative 1. And now I'm just going to do the math. Do order operations. 4 squared is 16. And then I would do negative 1 squared, which is going to be just 1. Then I can multiply these two numbers too also. 2 times 4 is 8. 2 times negative 1 is negative 2. So that went here, this went there, that went there, this went there. And now, just a matter of adding and subtracting from left to right. 16 plus 8, 24, plus 1, 25, minus 2 gives me 23. Alright. And now, if I look at number 15 here, with number 15, it's a little bit different, if you see. Instead of saying f of x, or f of negative 13, it says now f of x equals negative 13, and to find x. So whenever I see it written like this here, that doesn't mean you take negative 13 and plug it in for x, because what is the problem saying? It's saying find x. So what you have to do instead is you have to set your equation of f of x equal to negative 13. So I'm going to take 8 minus 3x, set it equal to negative 13. And now you go about, just as what we learned from how to solve equations, go about solving for x. So subtract 8. Negative 3x equals negative 21. And then divide by negative 3, and x is going to be not 3, but 7. And that, ladies and gentlemen, is how you work with function notations. Let me just take a look here. Alright, we'll end it right there for today. There's a lot of information I threw at you. Next class we'll look at a word problem and then how we deal with the graphing. So for homework, what I would like you to try is on these 2 pages here. So not the homework page, but on the first 2 pages. I would like you now to try the evens and see what you can come up with that. Alright, if you have any questions, make sure you email me and I'd be happy to answer them. This is Mr. Kizek signing off.